Welcome to CW 3.1. Today we'll be talking about the binomial theorem. So this is the theorem right here. So you can write this down if you want to, but notice this is pretty abstract. It's pretty high level. So to model the theorem, I'm going to give you an example that will show you how it works. So the binomial theorem is saying take a binomial, raise it to some power, and this thing is going to somehow generate all the terms. So I'm going to show you how this is going to work right now. The first thing to know is understand that a plus b cubed means this. A plus b times a plus b times a plus b. Now, of course, all of you can just multiply this, like power through, and figure it out. I'm going to show you another way to do it. What we're going to do is write down everything that could happen as far as the combination once you multiply. So what I want you to do is imagine these as three baskets. 1, 2, 3. Now, picture that you can only grab one thing from each basket, but you must grab something from each basket. So for example, I could grab A, and that would be A cubed. Now at the beginning, I'm going to put a blank. The blank's going to represent all the ways this could happen, so we'll not worry about that for now. Let's just focus on the variables. So I could grab an A here, A here, A here. Now what else could happen? I could also grab two A's and one B. So that would be A squared B. And again, the blank is for some number of them. We don't know yet. I could also grab one A and two B's. So that'd be A B squared. And I could also grab three B's, meaning no A's. So at this point, we can see that this is everything that could possibly happen. The only issue is we don't know how many there are of each. That's what this part is in the binomial theorem. This thing right here is called the choose function. And you actually already know what that is. The choose function is simply combination. That's NCR. It's just another way of writing it. So in higher math, you'll often see it written like this just because it's a little faster to write. Now the way it works here is to figure out how many A cubes there are. We'll first think, okay, there are three baskets, so I want 3 at the top. And let's think, how many A's was I choosing? Well, I want 3 A's, so 3 choose 3. For the next one, there are 3 baskets and I want to pick 2 A's, so 3 choose 2. The next one, there are 3 baskets, I only want 1 A, 3 choose 1. For the last one, there are no A's, so 3 choose 0. Now you plug in your calculator and you're going to get 1, 3, 3, 1, which means the answer is 1A cubed plus 3A squared B plus 3AB squared plus 1B cubed. Now notice how I did it from the perspective of the A's. You could also do it from the perspective of the B's. So I could erase all these, and I could think, well, there are no B's here, so I'll put 0. There's 1 B here, 1, and then 2, and 3. And you plug this in, you're going to get the exact same values, 1, 3, 3, 1. So that's pretty neat. And you also want to notice this here. Look at the powers that are happening. Notice how the powers always add these to n, this beginning number. So for your notes, what you want to do is put a little star here. The power of A and B always add to n. It's a very nice trick we're going to use later. So let's actually do it. Let's try this one. X plus 2 to the 4th. So what you want to do, call this thing A, call this thing B, and do it in terms of A and B. Okay, so think of this as A plus B to the 4th. We did the exact same thing we just did. Blank A to the 4th plus blank A to the 3rd B. And notice how I'm going to do a pattern here, because the powers of a are going down by 1. So I know this is a squared. Look at the powers of b. This, no b's, 1b. Now this is 2b's. So you can see the powers of b are going up by 1. So again, the powers of a are going down by 1. The powers of b are going up by 1. And then we're going to fill in what we know. So that would be, this is 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, 4 choose 4. And at this point, we're going to calculate everything. So let's grab our calculator. This is a lot of computation, so I'm going to show you how to do it quickly. We're going to go to Toolbox, Probability, Combination, 4, comma, and we're going to use a special bracket, Shift 8, that's a squiggly bracket, and we're going to put 0, comma 1, comma 2, comma 3, comma 4. That's going to calculate everything in one shot, 1, 4, 6, 4, 1. So that tells me these are going to be 1, 4, 6, 4, 1. Now we plug in a and b, so that's x to the 4th plus 4 x cubed, b is 2, plus 6 x squared, then 2 squared, plus 4 is x, and then b is 2 cubed, plus b to the 4th, so that's 2 to the 4th. Now simplify, x to the 4th plus 8x cubed plus 24x squared plus 32x plus 16. And there's your answer. So for this one, I'm just going to do the setup, and then you can try do it on your own to make sure you can do it. This is a, this is b. So we're looking for a plus b to the 5th. So notice how I carry that negative here, because you want to work with plus in the initial to make it easier. We'll do the negative at the very end. So blank a to the 5th plus blank a to the 4th b plus blank a to the 3rd b squared plus blank a squared b to the 3rd plus blank a b to the 4th plus blank b to the 5th. Now fill in the choose function. 5 choose 0, 5 choose 1, 5 choose 2, 5 choose 3, 5 choose 4. Oh, forgot to put the 4. And 5 choose 5. Now once you plug it into your calculator, you're going to get the following numbers: 1, 5, 10, 10, 5, 1. And notice the numbers will always mirror, which is really nice. And then plug in your a and b. So that would be 2x to the 5th plus 2x to the 4th power. B is negative y, so don't forget to plug that negative in. And then we just keep plugging in. And again, don't forget to plug in the negative value here, otherwise your answer will come out wrong. Okay, and then we're going to evaluate everything, and we're done. So that's 32 x to the 5th minus 80 x to the 4th y plus 80 x cubed y squared minus 40 x squared y cubed. This will be plus 10x y to the 4th, and this would be minus y to the 5th. Okay, circle that. Next one, find the 4th term. So obviously a question like this takes a long time. So what happens most often in like tests is questions like this, to make sure you can do it without actually having to calculate 7th power, because I would never make you do the whole thing by hand. That'd take you forever. So we just want to figure out the 4th term. So again, to do this, you want to think of this as a and b. So a plus b to the 7th. That's much easier. And again, let's just think generically. We got to find a pattern here. The first term would be something a to the 7th. That's your first. The second term would be something a to the 6th b, the first. The third term would be something a to the 5th b squared. And finally, the fourth term, the one we want, would be something a to the 4th b cubed. So this is the term we're looking at. Now your intuition might tell you, well, it's a fourth term, just make a to the 4th power. But that doesn't make sense because look at the first term. That's definitely a to the 7th, so that logic breaks down. What you want to do is focus on the b. This is b cubed, fourth term. B squared, third term. B the first, second term. No b's, first term. So we can see that term number minus 1 is equal to the power of b. And that's what you want to focus on here. All right, so let's keep going. So I know it's something, and then again, focus on this term number minus 1. So I know this is b cubed. And if that's b cubed, I know it must be a to the 4th, because these two numbers have to add to 7. And then this part, we're going to put our choose function. That'll be 7, and you can put choose 4, or you could put choose 3 here. Either one of these exponents will work fine. Okay, so I'll keep that there. I'll just rewrite it a little nicer. 7 choose 4. A is 3x, that's the 4th power. And then b is 2y to the 3rd. Okay, you plug in your calculator. And the answer is going to be 22,680 x to the 4th y cubed. That would be your fourth term. Well, the last one, very similar. It says from the last example, find the coefficient, so just a number in front, of this term, the x squared y to the 5th term. So already that tells you we're looking for the a squared b to the 5th term. So we always want to use a and b because that's going to be easier to think about. So going backwards, if it's a squared b to the 5th, and you put your slot here to represent the choose function, we know that there's a 7 choose 2 here, because again, we know it's the 7th power, or you could add these two together. And the 2 is from this a, or you could have put 5. And then from there, just plug it in. We know that a is 3x. So let's rewrite this, 7 choose 2. A is 3x, so 3x squared, and b is 2y. And then from there, plug it into your calculator, and you get 6,048 x squared y to the 5th. However, it's just a coefficient, so you just want to pull that out. And that's your answer, 6,048.